Hi, I'm Curt Frye. In this video, I want to complete the first phase of our Excel schedule building workbook for a sports league by reviewing what we've done and provide more calculations that we need to build a solver model to actually create a schedule. So it's very exciting. The sample file I'm using is called Build Model, and you can download it using the link that I provide in the video description below. So let's review what we've done so far in previous weeks, and I will zoom out so we can get a better view of what we have. Over on the left, I have the building blocks that are the schedule weeks. So I have all possible combinations that we need for 24 schedule weeks, and it's important to point out, for example, here in week 13, that one team does not appear. That is team number 2, so they don't play that week. And also, we have a team, in this case team number 8, that is scheduled to play itself. So that means they don't play either. And that kind of occurrence, missing out a week either because you're scheduled to play yourself or because you're not listed, is necessary because we need to fit all the teams in, and that sort of collision is just bound to happen. Over on the right, these yellow cells indicate that we will change the order of the match days to create an acceptable schedule, and I use a VLOOKUP to find the team that would go in each schedule slot. And currently, this grid and the one on the left are the same. I don't want teams to play a lot of consecutive home or away matches, so the first thing that I did was indicate whether a particular match is home or away. And then, so I have home here and away down at the bottom. And over on the right, I have a count of the consecutive away matches. And above that, I have the consecutive home matches. So what I need to do now is to add some calculations that I will include in the solver model at the end. The first thing to consider is that a week must have either 5 or 6 home teams and 5 or 6 away teams. And again, the reason is that sometimes teams don't play. So starting at 030, I will select cells from 030 down to 053 and press Alt to equal. And that gives me an auto sum formula that calculates the number of home teams. And in weeks where teams play themselves, and you can just see this up here, we have 7 and 7 and 6 and 6. So in that case, we have 5 home teams, and I will change the color of these cells. I'll make them gray, a light gray, and I'll also center the values. So we have 6s and 5s, and then each team needs to play 11 home matches and 11 away matches. So for that, I will select cells C54 through N54, and I'll type equal sum, and the range will be from C30 to C53. And I can't use an auto sum because I have a number here, and that would be included and throw off the results. Now I will type a right parentheses for the sum formula, and I will press Control Enter to enter the formula into every selected cell. And good, everything comes out as 11. And I will do the same thing I did before with formatting. So I have all of those centered, and I will make them gray. So you might have been wondering, because we're creating a solver model, we need to have an objective cell. So how in the world are we going to find an objective out of this? So what we can do is add up all of the home matches that are played in a particular week. And if I select cells 030 through 053 and look down on the summary bar, I see that the sum is 132. And if I select cells, let's see, C54 through N54, I get the same value, 132. So what that means is that I can set my objective cell equal to 0 as the result of subtracting the sum of all the home matches played minus the total of home matches played in each of the 24 weeks. So in cell O54, I'll type equal sum from O30 to O53, left parentheses, minus the sum from C54 through N54, right parentheses and enter, and that is a 0. Because this is our objective cell, I'll change its color so it's easy to identify. I'll make it green. So when we create our model, we want this value to end up as 0. I also want to limit the number of consecutive home matches and away matches. So I will scroll over. And I will select cells R54 through, I believe, AC54. Type an equal. And I want to find the maximum number in each of the columns, because that will be the number of consecutive home matches that each team plays. So in cell R54, I'll type max. And then that will be R30 through R53. Right parentheses, and then because I have relative references and I selected all the cells below, I can type right parentheses and enter, and there I have my maximum. And I will center those so they are easier to read, and I'll also make them gray as well. And the maximum will be the constraint that we use. So I want to find the maximum of the cells here, R54 through AC54, right parentheses and enter, and the maximum is 6. This is a constraint rather than a calculation, so my calculations are in gray, so I will make this a light blue. And I can do the same thing for the consecutive home matches. I don't need to use away matches over on the left because I already have my objective, but I do want to have a maximum on the number of consecutive away matches. So I'm there. And I will select cells. Let's see, this is R82 through AC82. That will be equal to max, left parentheses, then select R58 through R81, right parentheses, and then Control Enter. So I have all of my 6s and 5s, which match up to the number of consecutive matches above. And again, I will center and make that gray. And then the maximum will be the maximum of all the values here. So it'll be equal to max from R82 to AC82, right parentheses and enter, and I get a maximum of 6. And as before, I will make this into a light blue cell because it's a constraint. So with all of this in place, we can finally create our solver model. So I'll go to the Data tab and click Solver. There we go. So first thing I'll do is change this to evolutionary, because we're definitely going to make this into an evolutionary problem. It's not even nonlinear. Our objective cell, which is here, will be cell O54, and we want to set that to a value of 0. And we will reach that value by changing cells, let's see, Q3 through Q26. I'm already set to evolutionary, so now I can create our constraints. So I'll click Add. And each of these values, Q3 through Q24, must be different. So I've selected, through Q26. So Q3 through Q26, and then the comparison operator will be diff for different. Click Add. The same cells will need to be less than or equal to 24. Add. And then the same cells will need to be greater than or equal to 1. And finally, I need to set the constraints for the maximum of home and away matches. So I'll click Add, and then the first cell will be the maximum number of home matches that are consecutive. So I just click cell AD54, and that needs to be less than or equal to 3, we'll say. Click Add. Then we can do the same thing for cell AD82. That will be less than or equal to 3 as well. And click OK. So here we have our solver model. So we're trying to find an order of match weeks 1 through 24 where no team has more than 3 consecutive home matches and no more than 3 consecutive away matches. So I will click Solve and let the model run, and we'll see if we get a solution. We did, very quickly. So I'll click OK, and I'll scroll up, and I can already see here that I have maximum of 3 home and away matches, so that's good. I'll go up, and I'll zoom in a little bit so we can see the entire schedule. So the match weeks they're in a very different order than what we had before, but we have met all of our criteria. So this is one possible schedule. In week 1, we have team 3 playing team 4, team 2 is at home against 5, 1 plays 6, 12 plays 7, 11 plays 8, and 10 plays 9. And that actually works quite well because it means that for the first week of the season, which is generally very exciting, no team has off. So this is, at least at the start, a very good solution. And we see that breaks down in week 2, where week 6, or rather team 6, plays itself, and so they are not active that week. There are other problems with the schedule. For example, it might be that we have a team playing another team 1 or 2 weeks away, and it would be better to have a larger gap between teams meeting each other, home and away. So we can look at that in future movies, but I am very happy that in this case, we were able to generate a schedule where no team has more than 3 consecutive home or away matches, and also where everyone plays everyone else home and away across the 24-week season. I hope you enjoyed this movie and also the sequence that we used to create it. I'll go into more detail on creating and enforcing other constraints in future weeks, but for now, I think that we've come a long way and have a terrific project that we can call our own.